Welcome to our YouTube tutorial on setting up a CDC, Change Data Capture System with Postgres and Kafka. In this video, we'll guide you through the step-by-step process of setting up your database on Google Cloud, configuring whitelisting for local access, installing pgAdmin, creating tables, and finally, streaming data to Kafka topics using Debezium Kafka Connect. Let's get started. Setting up the database on Google Cloud. To set up the database, sign up for Google Cloud, which offers a free $300 credit for new users. Once signed up, follow these steps. Search for Postgres in the search bar and click on SQL. If you don't have an existing instance, click on Create Instance. Choose PostgreSQL as the database engine. Provide a name for the instance ID and set a password. Select the environment as Development and keep the region and zone as default. Under Flags, click on New Database Flags, search for cloudscal.logical decoding, and set its value as O. Click Create. And wait for a few minutes for the instance to be created. To access the Google Cloud Postgres instance from your local pgAdmin or dbeaver, you need to whitelist your IP. Follow these steps. Search What's My IP on Google to find your public IP address. Go back to Google Cloud, click on Connections, and navigate to the Networking section. Under Authorized Networks, click on Add Network. Give the new network a name, for example, Connect from Local. And paste your public IP in CIDR format. For example, if your IP is 171.76.86.52, change it to 171.76.86.024. Save the configuration, which may take some time to apply. Now let's create a user and password for the database. Click on Users in the Google Cloud Console. You'll see the username Postgres. Click on the three dots and choose Change Password. Set the password, for example, 1234, or choose one of your choice. Remember the password as we'll need it for the connection later.
Set up pgAdmin. To manage the Postgres database, we'll use pgAdmin. If you don't have it installed, follow these steps. Visit the pgAdmin website and download the appropriate version for your operating system. Once installed, open pgAdmin and click on Register Server. Give a name to your new server, e.g., My New G Cloud Server. In the Connection section, enter the following details: hostname. Go to Google Cloud, navigate to your project and the Postgres instance. In the Overview section, copy the public IP address and paste it here. Username, Postgres, password, use the password you set earlier. Click Save to establish the connection to the database. Next step is creating the database and tables. Now that we have access to the database, let's create the necessary database and tables. In pgAdmin, go to the Databases section and refresh it.
Oops! Forgot one thing. Before doing anything else, grant replication permission to this user. This is mandatory step, otherwise CDC data won't come to Kafka topic. In pgAdmin, go to the Databases section and refresh it. Create a new database called PinnacleDB. Once created, navigate to the PinnacleDB database and create a schema inside it. Copy and execute the SQL script to create all the required tables. Now, let's clone the repository and make some code changes for data generation. Update the host name in the code to your Google Cloud Postgres public IP. Modify the user and password variables to match the username and password you set earlier. Inside the repository's python/datagenerator/ecart_v2 directory, edit the datagenerator.py file. You can adjust the speed of data insertion by changing the value, for example, increase it from 150 to a higher number, or keep it as is. Update the connection details. Change the host to your Google Cloud Postgres public IP, leave user as Postgres, and change the password to the one you set. Save the file. Now, let's build the Docker image for the data generator. Go to the terminal and navigate to the ecart_v2 directory. Use the docker build command to build the image. Execute the command. Now we'll run the services using Docker Compose. First, let us understand our Docker Compose file present in infra directory. The provided Docker Compose file sets up a multi-container environment for a change data capture (CDC) setup using Postgres and Kafka. It includes the following services. 3 Kafka brokers, Kafka 1, Kafka 2, Kafka 3, are set up using the confluenting/cp Kafka image, each with a different port and configured with replication factors and listeners. The Kafka UI service hosts the Kafka UI, allowing you to manage Kafka topics and messages. It depends on the Kafka brokers and other services. The Schema registry service sets up the Confluent Schema registry for managing Avro schemas and compatibility. It depends on the Kafka brokers. The Connect service represents Debezium Kafka Connect, responsible for capturing and streaming changes from Postgres to Kafka. It depends on the Kafka brokers. Use the provided Docker Compose file to set up the multi-container environment for CDC with Postgres and Kafka. Switch to the root user and run Docker Compose up inside the infra folder. Open another terminal and run Docker PS to confirm if the services are running successfully. Access the Kafka UI by opening Localhost 8080 in your browser to visualize Kafka topics, brokers, clusters, and connects. Now, let's resume the data generator and populate our tables. Switch to the ecart_v2 directory in the terminal. Use the docker run command to start the data generator. Execute the command docker run my ecart data generator, and now let's check our tables. Voila! Congratulations! The data generator is populating the tables. Let's check for other tables as well. Oh, yes! We can see data getting populated in other tables as well. Once we have generated the data, the next step is to send it to a Kafka topic. To achieve this, we will utilize Debezium Kafka Connect, which is one of the services running through Kafka Docker Compose on port 8083. To send the data, we need to make a POST request using a specific request body. Let's go through the necessary parameters. First, provide a name for the connector, such as Inventory Connector. In the host name field, enter the public IP of your Postgres instance. Make sure to use the correct username and password, and remember that the username should have replication access, which we granted earlier using the alter command. In this case, we used Postgres as the username. You should already be familiar with the password you set. Next, specify a topic name for the Kafka topic where the data will be sent. For example, we can use My Second Topic. Once you have filled in all the required parameters, send the post request. If everything goes smoothly and the request is successful, you can verify the connector using Kafka UI. Open the Kafka UI and navigate to the Kafka Connect section. Here, you will find the newly created topics. Click on any of the topics and explore the messages. You will see the data flowing into the Kafka topic. If you don't find any topics, refresh the page. Oh yes! We can see streaming data coming to our Kafka topic in real time. Voila! You did it! In our next lecture, I will demonstrate how to consume these messages from Kafka. Stay tuned for that. That's all for now. Thank you for watching, and I'll see you in the next video.